This is the Anker PowerHouse 757. It is massive. It's, as of right now, as of recording this, it is the largest battery that Anker makes. Really, it's closer to what a gas-powered generator than, say, a power pack, just like a power bank. It's really designed to be more of a replacement for some applications or more applications that would be using a traditional generator. And so it's not to say that it's only for use for that. I use it for solar energy storage. I'll be talking about that use case specifically in a separate video, so get subscribed so you can see that when I do that video, because I just want to talk about it more generally. And specifically, this discussion is what it's like to have had this thing now for several months. A lot of the reviews that I saw that were already on YouTube are just reviews that someone did after having it for a week or a couple days, or maybe it was supplied to them by Anker. I haven't seen a lot that really cover it in depth. And so I think there are some interesting nuggets that I've pulled out in my investigation and analysis that you might enjoy. So stick around. I'll talk a little bit about solar. I'll talk a little bit about how I got some of the efficiency and capacity calculations, but it'll be a separate video on that. What is this thing? Well, first of all, it is a battery, and it is a battery with 1228.8 watt hours of storage, or 1.23 kilowatt hours of storage. Now that's the effective capacity within the batteries that reside inside this as the full assembled pack. We'll be talking a little bit more about what that means as far as actual effective capacity, because other things come into play. The big headline feature with this is it's the first battery pack that Anker has made that uses lithium iron phosphate technology. It is not using lithium ion or lithium polymer. So what does that mean? First off, generally, lithium iron phosphate will get you about 3,000 charge cycles before it reaches about 70 to 80% of its initial capacity. Comparing that to lithium ion or lithium polymer, you might get 500 cycles, maybe 600, depending on the chemistry and how the cell is being used. Also, lithium iron phosphate is a safer chemistry than lithium ion, so having this thing in an environment where it's going to be, say, used in an RV or used in a tiny house or an application where it's going to be sitting and used for many years, it's a step up in overall safety. In fact, it seems that like Anker is actually going toward lithium iron phosphate for all the applications that they sell batteries for. So before we go any further, let's talk a little bit more about these batteries. Anker said on their website that these are EV batteries. That perked my ears up a bit. So I looked a little further into the cells by basically looking inside of the power station and found out a little bit more about the batteries themselves. The designation of the cell is a TR26/70-40E. The rating is 3.2 volts with a total capacity of 12.8 watt hours. And that comes out to about 4,000 milliamp hour per cell at 3.2 volts. The company's name that makes the batteries for Anker is EVPS. On their site, you can see that they make a lot of batteries that look very similar to the ones that you can see inside of this power station if you kind of peek in through the side vents. The overall pack has a nominal voltage of 51.2 volts. And that's important for a couple of reasons. We'll get to that in a second. The biggest thing is total battery storage, which is at 1228.8 watt hours. What does that mean as far as the batteries inside here? Well, it means that you have 16 cells in series, and then 16 cells that are repeated in 6 parallel sets. It's a 16S 6P configuration in order to make this 1228 watt hour pack. Talking about the battery's capacity. What does that mean as far as what is available to the outputs on this? And specifically, on the AC side, it has the ability to output 1,500 watts with 2,400 watts of surge capacity. That's a bit different from every other Anker power bank or PowerHouse that is out right now that only has a upper limit of some wattage, say 300 or 500 watts if it's a PowerHouse 2400 or a PowerHouse 2800, and that's it. You go above that, the thing will cut out. This actually has surge capability. It at least puts it in the same ballpark as other competitors like Jackery, Goal Zero, Blue Yeti, because they all have surge capability. And so it's important, especially when you're powering loads like a sump pump or a refrigerator or anything that has an inrush current and a more inductive load, that's going to demand more of this power station as soon as it turns on and then settles back down again once it's running. The 2400 watts is kind of low compared to a lot of the other competitors out there that might have usually a multiple of 2 from the nominal rating. So in this case, it's 1500 watts, it'd be around 3000. As far as the DC, the car socket output, the car socket has a 12 volt, as you might expect, but it's actually a little bit higher than 12 volts. I think it's about 14 volts. But 12 volts, 10 amps is the max output, so 120 watts. And then in the center, you have all of your USB. So you have your USB type C at the top, one with 100 watts and one that supports 60 watts. And then all the USB-A support 5 volts at 2.4 amps. There's a couple interesting features that are on this that I think kind of got misrepresented or incorrectly discussed in previous reviews. And that is the way that this thing charges. And what it has on it is very similar to another Anker battery, which is this PowerCore Plus 26800, and some of the other PowerCores actually have, well, which is they have a single input on them, this USB-C power delivery port, and this power delivery port can be used for charging and discharging. So what it's effectively called is a bidirectional DC to DC converter. And while this particular one, has a power rating of about 30 watts, and I think this one topped out at around about 87 watts, this has an inverter in it that is rated at 1000 watts. And it uses this inverter for both charging and then providing DC output to all of the DC loads, as well as some of the initial stage input that is used to provide the AC output. Now, the input is rated at 1000 watts because if they were to go higher, it doesn't benefit anyone really to go higher than that. You don't want to load up a single AC circuit to, say, 1500 watts, because then you need a dedicated circuit to charge this thing. And I still would recommend doing that when you charge it because it uses 1000 watts when it's charging. And it will take the battery from 0 to 80% in 1 hour. So that's great if you're experiencing a situation where you need to get this thing charged quickly, either for emergency preparedness, or if you're using it somewhere and you realize, oh, it needs a charge and you want to charge it up quickly. But if you plug this thing in on a circuit with a bunch of other things, then you might experience a circuit breaker popping, especially if it's on a 15 amp branch. As far as other ways to charge this also has the ability to be charged via solar and via a DC accessory socket in your car. They both use the same XC60 connector. It's basically limited at a current of 10 amps. In the car, hang around 12 volts at a little less than 10 amps. It kind of hovers around 9 amps when it's charging. And the solar, the configuration that I have is actually about half the maximum that you can provide this, which is 300 watts. Because again, it's limited by current and obviously voltage to how high a series voltage you can have on the solar panels. But it's limited to 30 volts DC at 10 amps. So the setup I have is 150 watts, and it basically hovers around 14 to 15 watts when it's a pretty bright and sunny day, and delivers about 115 to 125 watts to this unit. And that is at around between 8 and 9 amps as the input currents. For more on my particular configuration and usage with this, some of the things that I experienced, charging it via solar, I'll be doing a separate video on that for this battery. That said, this does have MPPT functionality on it. The build quality, it's very good, consistent with what I've experienced with Anker's products thus far. All the buttons have nice clicky actuations. I mean, there are not that many functions on it. It's a pretty simple layout, but all the switches and things feel like they're gonna last and don't feel like they're built down to a price, because this thing has a 5-year warranty on it and it's designed to run for 50,000 operating hours. It's impressive that Anker's coming out and laying a course for these types of devices to last many, many years as compared to some of the other competitors out there. Now, some of the other competitors out there make devices that may have shorter warranties, but they've got the history to show that they will last much longer than what their warranty might suggest. So Anker being a newcomer in the higher capacity battery power station arena, I think they kind of needed to do this in order to make headlines, so to speak. But it's not just fluff, it's an actual 5-year warranty. The other thing about the build quality is the cooling system. On the right-hand side, there are 4 fans that they seem to me like they're kind of like server grade fans, because they are very high velocity, high RPM fans, and they just kind of sound like they come from a server. Having worked around servers for quite a while, you can hear for yourself what these things sound like when they're going full blast. There are two on the top that are dedicated primarily to cooling across the very top part of this unit, which is where the DC to DC converter exists, the AC to DC converter exists, and also the DC to AC conversion exists. That is for providing DC to AC output. Lower, there are two fans mounted one above the other. So on the top, there are two that go from front to back, so they're sitting next to each other, and then one above the other, lower down in the power station, that are used to cool the batteries. Those have come on a couple times. It took a couple of months for those to come on, but then it got near the middle of summer and the power coming into this power station was peaking at around 140 watts, 145 watts on some days from the solar. In the area where it was sitting, it warmed up enough where the fans came on. They were very, very quiet. When it is under high load, especially if you're running it at 1500 watts or very close to 1500 watts, the top two fans come on immediately and you will hear them. But for anything below about 700 watts on the AC output, you're not really going to hear the fans at all. In fact, they're just usually off or at a very low speed and they're not obtrusive really at all. The user interface is super simple. In fact, it might be, for some, a bit too simple compared to some of the other options that are out there that they cost more, but they have a lot more functionality that's user configurable. There's not much that's user configurable on this. You get a display telling you what the battery state of charge is, whether or not you have power saving turned on or off. And then you have a few buttons that just control various functions, like turning on or off the car socket, which you get a little icon on the display that shows you that it's been turned on. The AC outlet, which also tells you that it's been turned on. There's a little light bar on the front that has 3 intensity levels. There's low, medium, high. Really not much to see when it's blasting back at the camera. The other thing of note is the power savings functionality. And it's a simple little function, but it's a pretty important one. If I have it on right now, and I have the AC outlets just turned on and the car socket turned on, and I don't do anything, I don't plug anything into it, after an hour, it will turn off the car socket and turn off the AC outlet because both of these things require step up or step down conversion. In the case of the car socket, it's got to step down from 51.2 volts nominal to about 14-ish volts. And in the case of the AC outlet, you're going from 51.2 volts DC to convert that into 110 volts AC, which is about 160-ish volts peak. You don't want these things running continuously unless there is a load that requires them. So if you're running a refrigerator, for example, you don't want to keep the power saving on because when the refrigerator turns off, its power consumption drops to almost zero. But if this thing were to turn itself off, then your refrigerator obviously isn't going to work. Or something's drawing a low amount of power, say a router or something like that you're using in a blackout situation, you're going to want this thing to keep running even if it's at a low power consumption. For the AC outlet, basically if it drops below, I think 10 watts, for an hour, it will shut off. And in the car socket, I think if it drops below 2 watts, it will shut off. As far as the USB stuff, it doesn't matter. It will keep operating no matter what it needs. The display has a few additional pieces of information on it that I haven't mentioned as of yet. One is the output, which is how much power it's using right now while it's turned on. As far as it predicting how much runtime it has, it's a little fuzzy because if you have something that's more of a variable load, like I'll get to in a minute, it really can't predict it very well. It's just kind of averaging and giving you some kind of a semblance of like, hey, if it keeps running like this is how long it's going to run. So if you have a continuous load on it, it gives you some kind of idea of what's going on. As far as the AC outlets, they're pretty good. I wish these were a little bit more positive grabbing force on them. They kind of have this click-in feel, which is good, but it's not like a standard outlet that you'd have in your home, especially for these 2-prong outlets like you use for the power adapter. They do grab the power adapter very well, but there's just a point where they're a little bit loose if you pull back on it a little bit that you don't get in a wall outlet. But I haven't had any issues with anything sagging or falling out, so it's similar to other Anker products though, so whatever they're using is at least consistent across the range of products that they make. I wanted to come back to efficiency and capacity. I started talking about that a little bit earlier, but then I wanted to put it all together here. Obviously it's 1229 watt hours, but if you're testing this thing out, you think you're going to get 1229 watt hours out of it, you're going to be disappointed just like you would with any other battery pack, power bank, anything like that. You never get the complete capacity from all of the cells combined because there's internal losses for one. And also this unit is configured to have a minimum depth of discharge that it will permit before it shuts off. From my testing, it's basically the same as all the other units that are out there, which is about a 90% depth of discharge, or it'll leave 10% remaining. So doing any sort of measurements and calculation, I never expect to see that I'm going to get 1229 watt hours out of the unit. But I did do some capacity testing over the months that I've had this. I did it in two ways. One that's focused on DC outputs and one that's focused on the AC outputs. And because basically the AC is going to vary based on what kind of load is plugged into it. So if you plug something in there that is a very inductive load, say a fan that doesn't have any sort of power factor correction on it, or a sump pump, any power tools, they even show like a jackhammer, like some of these tools, they show you're going to get 3/4 of an hour out of this thing if it's pulling about 1500 watts from the unit. And why is that? Well, when it comes to the AC side, not only do you have to be cognizant of the 90% depth of discharge, but also there's a conversion that happens between DC to AC. And so in this unit, it's about 92% efficient, and it can go up from there depending on the type of load plugged into it. And so what I did, I used two different loads as a representative set. One was a purely resistive load, and it was a smaller load, about a 200 watt portable space heater. And then I just tested that by itself. And then the other one, I just used a standard portable dishwasher. Go with the dishwasher first. That one is variable loads. It has a variety of different types of things in it. Pumps, motors, a heating element to heat the water up. It has all these different things that are resistive with high power factor, a motor, pretty good power factors, and then like solenoid, when I have poor power factor. And so it gives it a good range of things that are operating to get an idea of what its capacity is. So what I did is I just used a power meter, compared its measurements to what the owner's manual says for the actual cycle power consumption, and they matched up with each other. And then I just used this in conjunction with the dishwasher to get an idea of what the overall power drawn from the unit was. And in this particular case, I used the eco mode on the dishwasher because I wanted to aim for trying to get like complete cycles of the dishwasher. With this thing fully charged, I was able to get 3 wash cycles through a dishwasher before this battery depleted. That comes to 930 watt hours discharged from this unit. And so if we take that and we divide that by the efficiency of the unit, which is 0.92, that gets us to about 1,010 watt hours actually coming from the battery pack itself out through the AC outlets. And we divide that then by the total amount of effective capacity, and we get 82.2% efficiency of the battery pack. With the lower power load, about 200 watts, that was purely resistive, that ran for close to 5 hours repeatedly. So I was able to get about 1,000 watt hours out of the unit, and you divide that by, again, 0.92, and it gets us to about 1,086 watt hours. Divide that by 1229, and we get to about 88% of the effective capacity of this unit. And I would expect it again to vary up and down. Right out of the gate saying, well, it's not at 100% or over 100%, that means it's defective or not representative of the actual capacity. No, it's more this thing deciding when it's going to cut off power. Using Anker's system on chip, it might just choose to shut off the device a little earlier or a little later depending on the various loads on it at a given time. On the DC side, it was higher than that because the conversion ratio from higher voltage DC and a step down configuration is definitely much higher, approaching 96, 97%. So I was able to easily get in the range of 1,050 to 1,100 watt hours out of the units. And so that divided by 0.96, then divided by 1229, gets us to about 93.2. If we take all these and divide it by 0.90 to indicate that we've only used approximately 90% of the battery's capacity, 10% is in reserve because that's the amount of depth of discharge. Just to take one example, the 1,050 on the DC side divided by the 1229 gets us to 85%. Divide that by 0.96 and we're at 88%. And then you divide that by 0.90 and it gets us to 98.8%. So we're basically right at the capacity of this battery. I feel fine about what they've stated the capacity at compared to what you get out of it when you use it. But I think it's an important thing, if there's a TLDR of all of what I just said, is keep in mind, just like any other battery pack, this is effectively a 1 kilowatt hour pack. It is not a 1.229 kilowatt hour pack because 10% of that is going to reserve capacity in the battery. And then yeah, there's going to be some losses in the DC to AC conversion. That's why you always want to use DC whenever you can. So one function that I haven't tested that is an interesting piece is the battery backup. That said, I was concerned about the use cases of this, especially if it's going to be used in an RV or a tiny house or van living or as supplemental power, things like that. And also, in some ways, a replacement for a traditional generator. I looked up if there was any third-party testing done on this unit. And initially it was hard to find, but I did eventually find a marking on the bottom that I haven't seen before. Well, it's one that I've not seen frequently, and that's an SGS mark. And so this Anker power station has been evaluated by SGS to two important standards. The standards are the ANSI UL 2743 and UL 1778. And so I'll go with the UL 1778 first, which is the standard for uninterruptible power systems. So it's great that they've tested this to be an uninterruptible power system and not just claiming it without having it being tested. That's great. The other one is the ANSI UL 2743, which is a very interesting standard. This is designed specifically for safety in portable power packs. But it is a standard designed around things like this that have a giant amount of battery capacity in them, have different types of converters, different ways to charge, different ways of output, and to ensure that there is safety in these types of devices. It stands to reason that if you want to make sure this thing is actually safe and not going to cause fire or shock or hazard related to the battery, that you'd want to evaluate this thing at least like you would the power supply, but also take into account the fact that there's a whole bunch of batteries in it and different types of ways that it interconnects. All that's been tested. One thing that I want to mention is that this does show it being used in outdoor applications. And I would strongly recommend that if you use it outside, it has to be dry out. The louvers on the sides, that it's not designed to be used in any sort of wet environment or an outdoor environment where it may get wet. Now, if you have it in a dry space, outside, say, in something that is keeping it dry, and you have things plugged into it, and those things run off to things that are outdoor rated, that is okay. Like most of the things that are kind of this capacity, above 1 kilowatt hour of storage, it's not light. It's about 44 pounds. Now, the handles make it much easier to move it around. It's got these nice handles on the top here. Compared to a lithium ion or lithium polymer device, it might have weighed a little less, but because Anker put all the technology into it, the charging, discharge, all the stuff together, there's no external power brick to plug into it or anything like that. The additional weight doesn't really bother me. And it is one of those things that you plug in, it charges. I sometimes will plug things into it while it's charging and it'll pass through. I don't move it around a whole bunch. Where I have smaller packs, I move them around much more frequently because they just don't weigh as much, but they are lithium ion. There are only a few things that I would mention that I've had some issues with. Two things primarily. One is that there's no way to keep this display on, even in its dimmed state. I'm sure you've seen throughout this video so far that it starts off in a higher intensity level and then it drops down to a dimmed state and then it turns off. And there's no way by holding down the button or doing anything with the button to keep the display on. That plays into my second frustration with the unit, which is it doesn't give you any real good notification of when the battery is about to be depleted in any mode, whether it's the car socket, USB-C, USB, or AC outlet. I have two other PowerHouses, PowerHouse 2400 and a PowerHouse 2800, and both of those operate the same way. Get down to 1%, the display starts blinking, it blinks the actual thing that whatever's plugged into it, and then will turn off. So it really doesn't give you much warning that it's about to run out of battery. That to me is pretty frustrating when you're using something, especially if you're using it for applications that you might run out of battery and you know that, and you want to know where you're at and perhaps being given some early warning. And 1% is really kind of right at the level of being useless, especially if it's a higher wattage load. Lower wattage stuff, okay, fine, I'm down to 1%, I got an hour left if it's like a 10 watt load or something like that. But even then, there are times, I guess this is my third point of the two. The third thing I've noticed is that its interpretation of what capacity it has, it gets confused and just drops from 20 or 30%, and I'll look at it and I'll push the display button half an hour later and it's down to like 6. And it's like, well, what happened? It's not a particularly demanding load, maybe 10 to 30 watts. What happened? I don't know if that's just teething pains of an early design and Anker's worked that out. There are other things that I'll discuss in the solar video. Thanks for watching. I hope you enjoyed this video. If you like what you saw, please like and subscribe so I can keep doing videos like this. I will see you in the next one. Take care.